Well, let's talk about frequency response. Timer started. So, John, you did make a absolutely correct comment in one of our amplifier series videos about the importance of looking at the entire frequency response, not just specific channels when you're setting up amplifiers and looking for impairments. So, for that reason, I wanted to go ahead and record this one, and let's get all of the frank discussions out there about why it's important to look at the entire frequency response of your system and not just certain channels when you're setting up your amplifiers. So first of all, what is frequency response? Do you want to take a swing at explaining that one?
It's frequency versus amplitude, right? So on the bottom horizontal x-axis would be your frequency. Some people might say channels or frequency. And on the y-axis, the vertical axis, you have the amplitude, usually dBmV. In Europe, it might be dB mu V, reference to a microvolt instead of millivolt. But either way, it's reference to something. So it's a level we're looking at. For that trace on the left, and that very much looks like the old SDA, WaveTech, Wandel Ultraman, Acturna, what's the new name?
Viavi. Yeah.
Viavi. It was JDSU at one time as well. And I worked at WaveTech years ago. So that definitely looks like the old SDA 5,000 meter. And it's a downstream response, it says right there, from what, 30 or 40, 50 megahertz up to 750 maybe?
Yeah, 555 to 745. And I will tell you that the first meter that I got where I felt that I had arrived was a Stealth 3SR. That was the coolest meter ever when I was a brand new sweep tech.
In the R, I think, meant return, 3SR, or receiver. I remember receiver. So 3SR was a stealth system sweep receiver. And I think it was what the 3S meant. I have a lot of history with that. And it's funny you bring up that you talk about frequency response and standing waves. And when the SDA meter first came out, we had a lot of people with high-end frequency ringing. So standing wave, but from say 550 to 750. Turned out what it was is if you hooked up your test lead to say a 20 dB down test point, the signal levels were so high back then coming out of the trunk or a bridger amp that with a 20 dB down test point, it was still pretty high. And that level was bouncing back and forth between the front end of the test equipment and the test point. So you had a standing wave on your test lead. Had nothing to do with your plant. So you're trying to track down a plant problem, and it turns out it's your test lead problem.
You're chasing a ghost that doesn't exist.
Yes, exactly. And that's why I say it's like you're only as good as your reference or, what you're looking at. So if I would have referenced that out and then went to a good test point, then it would have looked the opposite of it. And I would have been tracking down a standing wave that wasn't even there. Yeah, right. So it can be really frustrating if you don't know what you're really looking at. So sometimes I might have said, let's do a sweepless sweep where I just look at all the channels and the test equipment just kind of connects the dots between real channels.
Yeah, and that's really the difference between that raw sweep, which is just the unreferenced sweep response, right, or the frequency response, versus a reference sweep. Like we were talking about before, this is a referenced return sweep, which is really flat. And unfortunately, we've referenced some responses that weren't flat. And then we set up every amplifier after it to make it look like the first one. Right? When in reality, what we did was bake that tilt into every amplifier just because of our referenced response.
Yeah. And you were talking about like balancing amplifiers. And to me, sometimes I take a step back and say, what's the purpose of sweep? To me, the purpose of sweep is to see anomalies like frequency response problems, suck outs, high end roll off, low end roll off, standing waves. But in my mind, it wasn't really meant to find ingress sources. So when I did upstream sweeping, I never put a sweep point at 27 megahertz because I didn't want to capture CB radio. That wasn't the purpose of my sweep. My sweep was to balance it, align the amplifiers, and look for standing waves frequency response. If I'm looking for ingress and things of that nature, a spectrum analyzer is probably my better tool. Return path, spectrum analysis, looking at real-time things popping up, knowing how spectrum analyzer, you can change the sweep time and dwell time and all this other stuff. that's another story, right? That's a different
Yeah,
topic.
well, so but it is important, right? Because if your return isn't aligned properly, if you don't have the right amount of attenuation and you have too much gain at different points in the system, you can actually exacerbate an ingress condition, right? So the level is important, but in the context of having unity gain and not over amplifying noise and under amplifying signals.
Yeah, you could you could overcompensate if I didn't do each amplifier and passive in between each active to balance that gain and loss, and I did 2 dB less on one and 2 dB more on the other. The system might look fine, end to end. But now, if you underdrive one of the amplifiers, you have worse carrier noise, right?
Yep.
The lower the level, hitting that first hybrid or whatever is usually low carrier noise. If you start running too much level on the upstream, we're not at what's the word for it? As it's not as harmful in the upstream because we don't have as many channels. On the downstream, we have so many channels that are always on. They're not bursty like the upstream. Downstream is always on. If the levels are too hot, we could have more distortions. And now that all the channels are not coherent video channels every 6 megahertz apart, they're big chunks of noise, 6 megahertz chunks of noise, QAM, and then OFDM. The intermixing doesn't look like CTV and CSO anymore. It looks like composite carrier intermodulation noise, just a higher noise floor.
Yeah, I do think that's a conversation for another day, though, because as we talked about in a previous edition with DOCSIS 4 and having potentially return signals all the way out to 684 megahertz in some cases, there's a chance that we could end up with some upstream distortions if the amplifiers aren't properly aligned. In the same way that we've chased that problem on the downstream for a long time.
Agreed. And the fact that the more traffic we do, the more that signal is going to be on.
Yeah, that's right.
To burst the upstream signal, each modem transmits when it needs to, but the more traffic we send, the higher speeds we give, the more the signal is going to be on, the more intermixing you're going to get.
Yeah, and the more funneling on the upstream that you're going to see, it's typically the first amplifier out is going to see more upstream energy at the port input than, say, an amplifier farther out on the periphery.